Hello, thanks for clicking. Welcome to another Narculus production. Today we're going to be talking about slope fields, which, believe it or not, is a field of slopes. Okay, so there's not much else to say other than that. So let's get started. All right, let's solve this differential equation. So we know how to solve differential equations. We do separation of variables. And we're going to solve this differential equation. dy dx equals x plus y. Okay, here we go. So I'm going to multiply both sides by dx. Let's do that. So we have dy equals x plus y times dx. Okay, now I got to move the y over to the other side, right? So I'm going to subtract it, but I can't subtract it yet because it's in parentheses. So I have to distribute this dx first. All right, let me distribute the dx. I have dy equals x dx plus y dx. Okay, I want to subtract y on both sides. Move that over. But wait, hold on. I can't subtract y because there's a dx stuck next to it. I'd have to subtract y dx. So that's a problem. Right? If I move y dx over, then I'll have dy and dx on the left-hand side. That's no good. That's not going to work. Nope. So that's no good. Okay. So what do we do if we can't get our y's and dy on one side and x's and dx's all on the other? So the issue that we have with this differential equation is it's not separable. You can't use separation of variables to solve this differential equation. Now, there's another way you can do it. Okay, there's other techniques that you can use, but we don't know them. All right, so we're kind of out of luck in terms of being able to solve it. So we can't algebraically solve it. But what we can do is we can use a slope field to look at what the solution would look like. See a picture of it. So let me show you. So a slope field is a group of tangent line slopes on the coordinate plane that can be used to show the solution to a differential equation. So this is the slope field for dy dx equals x plus y. So what you see here is, well, hundreds or 100 slopes, right? 100 different slopes for a tangent line. So here's what's happening. For example, let's take the point, 5, 5, let's say. So what they're doing to create the field is you're taking the point 5, 5, you're plugging it in. So dy dx would be 5 plus 5 is 10. Now, dy dx, that's the slope of the tangent line. So we're saying that at the point 5, 5, the slope of the tangent line to the graph is 10. So let me explain to you what I mean. So let's say I drew a graph like this. Here's my parabola. This is f of x. So for f of x, what I could do if I wanted to is I could draw slopes, right? I could draw a bunch of slopes of tangent lines if I wanted to. There they are. Pick random points on the curve, draw slopes of tangent lines. There they all are. Okay. Now, if you look at the points in blue, now I'm going to try to erase the f of x that I created in black here and see if I can get it to go. Yes, and not erase the blue. If you look at just those slopes of all those tangent lines, you have a pretty good idea of what f of x looked like, right? Before I erased it. Or after, before I erased it. It was a parabola that opens up. That's the concept behind slope fields. Okay? So you're going to draw this field of slopes, and then with the field of slopes, you can see what the picture y would have looked like depending on where you are on that coordinate plane. All right? That's the idea behind it. Okay, so if you're working on the AP exam or really anywhere in Calc 1, there's really 3 things that you have to understand about slope fields. The first thing you have to know about slope fields is how to draw a slope field. Okay, it's pretty easy to do. So we're going to consider this differential equation. It's a different differential equation than one we looked at a minute ago. All right, dy dx equals 1 plus y over x. I want to sketch the slope field to the differential equation at these 8 points. So I'm giving you 8 points and saying, here, go make the field. Okay, so we got to plug in all 8 points and see what we get. Let's start with negative 2, 0. That's this point over here. So dy dx at negative 2, 0 would be 1 minus 0 over negative 2. So negative 1/2. Okay, let's keep going. We're going to evaluate all of these, and then we'll draw them all on the plane over here. So let's go to negative 1, 1. So negative 1, 1. dy dx would be 1 plus 1 over negative 1, so negative 2. All right. At negative 1, 0, dy dx would be 1 plus 0 over negative 1. It's negative 1. At negative 1, negative 1, dy dx will be 1 minus 1 over negative 1. It'll be 0. Oh, that's a good one. Let's come over here. That's those 4. 1, 2, 3, 4 points so far. That's these 4. Let's go to these 4 on the side. Let's try 1, negative 1. Okay. Again, we're not picking random points. We're picking the points that are literally on this coordinate plane that they're telling us to use. And that tends to be the way they make you do it. So this is 1 minus 1 over 1. So that's 0. At 1, 0, we get dy dx would be 1 plus 0 over 1, 1. At 1, 1, we would get 1 plus 1 over 1, 2. At 2, 0, we would get 1 plus 0 over 2, 1/2. Okay. All right. Now what we're going to do is on our slope field, we at each one of these points, we're going to draw a little tiny segment that approximately has the slope that we calculated. Will it be exact? No. Okay. But there's a couple things to think about. So at negative 2, 0, we want to draw a slope of negative 1/2. So your slope that you draw better be negative. So it better be going down the hill. Okay, so let's say that. At negative 1, 1, our slope is negative 2. So it has to be negative, and it has to be steeper, or it should be steeper than the slope at negative 2, 0, because that slope was only negative 1/2. At negative 1, 0, it's negative 1. So that's somewhere in the middle as best we can. At negative 1, 1 is 0. So that's just horizontal. Yep, that's the one I like. And then over here, 1, 0. 1, 0 is 1. So you want to try to make it match the slope as best you can. But now it's positive. You know, you're not going to get, it's not going to be perfect. Okay. At 1, 0, or I'm sorry, 1, negative 1, it's 0. And then we're going to have a slope of 2. And then we're going to have a slope of 1/2. And there's our slope field. Now, we can't draw anything through the slope field. Okay, we can't draw anything. I don't know what the solution to the equation actually looks like graphically. There's not enough information here. There's a whole lot of pieces missing, right? You need a big slope field like the one we had earlier, which we're going to show you in just a second, to really get a good idea as to what, actually the picture actually looks like. All right, but that's how you draw a slope field. Okay, now, given the slope field below, draw the solution through the point 0, negative 3. Okay, there's a few things you need to know about drawing through the field and what you are drawing. When drawing through the field, you are drawing the solution to the differential equation. you're drawing its solution. Okay? So, when you draw, you must draw a function. You must draw a continuous function. All right? If there's an asymptote or something in the middle, the curve stops. Okay? Your solution curve stops. You have to pass through the given point. In this case, 0, -3. I have it highlighted here, 0, -3. We're going to pass through that one. And number 4, you should draw your solution from one end of the field to the other, but don't use arrows. So basically what we're going to do is we're going to draw this like we're in a lane, right? Almost like it's a race or something. We're racing in our lane. So here's our lane. We're going to try to almost trace over the slopes a little bit. We want to go through this point. Yeah, there we go. Oops, no arrows. So used to drawing arrows. Oh, I missed the whole thing. Got to try it again. So if you missed it the first time, here's your chance. See it again. There we go. Up and all the way through the graph. This solution is the solution, or this graph is the solution to the differential equation. If you were to separate the variables and solve it, this is the graph that you would get. Okay? That's what you're drawing. All right? So you have to know how to draw through a slope field. And finally, you have to be able to figure out which differential equation is represented by a slope field below. So given the slope field, which of these will match up with that? All right, so now to do this, here's my suggestion. The first thing I suggest is you look for slopes that are 0, because those will help tremendously. So the slope is right there. All these slopes are 0. So dy dx is equal to 0. So this is multiple choice. One of these is the correct answer. I'm going to try to eliminate the wrong answers. Okay? If the x value is -1. So when the x value is -1, I get a slope of 0. Okay? When the x value is -1, the slope is always 0, no matter what the y value is. Okay? Y could be anything, but the slope comes out to be 0. All right, let's come over here. In letter A, if x is -1, well, if I pick anything else for y other than 0, the slope is not 0. But this is saying the slope is, so that's not it. Okay, in letter B, if I factor out the y, let's say y times x minus 1. So if I plug -1 in there, I get -2 times y. And that's not it either. All right. If I factor out y out of here, I get x plus 1. Okay, that's possible. If I take -1 and plug it in for x here, it's going to give me 0 no matter what. So that's a possibility for an answer. If I take out x there as a GCF, I get y plus 1. No, that's no good. Because if I put -1 in for x, I get a negative out here. But any number I plug in for y other than -1 won't give me 0. So that's not the answer. And then E, if I put -1 in, yeah, I get 0. So I'm down to 2 choices. It's either C or E. So I'm going to keep looking around and seeing what else I can find. Okay. So the other thing you can do is look at the actual slopes themselves. So for example, look for patterns in the quadrants. In quadrant 1, it looks like all the slopes are positive. We agree? Well, that would match. So when the x is positive and the y is positive, dy dx is positive. In quadrant 4, if x is positive and y is negative, oops, not -1, just a negative. Okay, so x is positive, y is negative. The slope is always a negative. All right. Y is negative, x is positive. That still could be the answer. If x is positive, no, okay, all right. So letter E, when x is positive, if I put a positive number in here, add 1 to it and cube it, more than likely it's going to be positive, right? Anything bigger than 1 is going to make it a positive answer. But all these slopes, when you're bigger than 1, are all negative. So that's not it. So C must be the answer. We're using process of elimination to eliminate the differential equations that don't make sense given the slopes that we have on the slope field. Okay? And that's what you have to know about a slope field. You have to be able to make a slope field, draw through the slope field, and figure out which differential equation matches up with a given slope field. All right? And again, slope fields can be used for things that are not separable. Okay? And if you want to look at what a solution might look like. And as always, thanks for clicking.